We are honored to feature Chris Vizas of SmartSensecom and Bruce Walker of the Analysis and Resilience Center for Systemic Risk. Chris and Bruce will discuss the power grid's continuous transformation into a resilient, flexible, and secure network of networks. They'll touch on the grid as it exists today, how to mitigate cyber-physical risk, and the promise of sensor technology. We hope you enjoy the conversation. Hello, my name is Pete Saronis, and I am super excited to bring the first episode of the Utility Supercluster in 2021 to you today. I am honored to be with our guests, Mr. Chris Vizas, Chairman and Founder of SmartSensecom, and Mr. Bruce Walker, the Chief Risk Officer for the energy sector at the Analysis and Resilience Center for Systemic Risk. For those of you tuning in, the Utility Supercluster is focused on energy, water, and waste management, critical infrastructure sectors in our country that we depend on every day. And there are people globally who are doing great things with intellectual property, discovery, passion, entrepreneurial spirit to bring some of this technology to the future workforce, to the future grid. And today we're going to talk a little bit about some of that incredible innovative technology and groups like Bruce is leading to help get the word out as we address a future that is somewhat digital, somewhat ubiquitously connected, and really converges this information technology world with an operational technology world. So Bruce, Chris, great to have you with us today.
Great to be here.
Great to be here.
Awesome. Bruce, I'm going to pivot to you first. If you can, in your illustrious career, which I'm promising to my guests, I'm not going to have to go through every bit and piece. You know, you've had a recent stint at the United States Department of Energy, serving as the Assistant Secretary for the Office of Electricity. You're now at, of course, the Ark as the Chief Risk Officer. I would love you to talk a bit about the Ark, its mission, and how your journey from your time even in the utility has really shaped your passion and mission for this very topic.
Sure, thank you for that. So the Ark's mission is really about identifying systemic risk across both the financial sector and the energy sector at the moment, identifying the interdependencies between the two and other sectors, and then really understanding what those risks are from a standpoint of impact, threats, and vulnerabilities, as you're very well aware, and I think the world is witnessing. Things like cyber threat is something that's very real in today's day and age. And we look at finding ways to eliminate and or mitigate those risks that are in fact systemic, that would impact one of our two sectors. As time goes on, there'll likely be other sectors that get involved that are, critical to lifeline components throughout the United States, public health and safety, things like the communications industry. And working through those, the opportunity really is to bring together both the industry and the government and work in a cohesive way to build risk registers and develop initiatives that are going to address those highest risks for the national security as well as the economic security of the United States.
Yeah, thank you, Bruce. And I know throughout this discussion, I may bring up, but please reference some of the amazing work that you led at the department, which I personally know, and I think that our community would be fortunate to understand in terms of your work designating critical defense facilities, defense critical electric infrastructure, your work, and I'm reading off some of this, acting as the Assistant Secretary for the Cybersecurity, Energy Security, and Emergency Response when it was initially established. And there's just so much more. Deputy County Executive at Putnam County, New York. You just have an incredible and breadth of experience that I think can make this conversation today real for a lot of our listeners. So thank you, and we'll hit on some of that for sure.
Great.
Thank you. Yeah, Mr. Chris Vizas, a gentleman that I've gotten to know here in the past couple of years, chairman and founder of SmartSensecom, as we mentioned, has spent the last 40 years. First of all, love the bow tie, Chris. It's just, you're distinguished anyway, but extra today. 40 years helping this technology agenda in our country evolve into one that requires that balance between government, industry, and academia. Can you talk a little bit about, take that journey of yours and what SmartSensecom's not just mission, but the value that you feel is one that our country and our world is going to benefit from?
Well, to take a page from what Bruce was saying, Smart Sense is all about identifying risk operationally, as opposed to strategically or in the long term. Its purpose is to take a technology developed by the US Navy. And the company was founded by myself and its chief scientist, who is a retired scientist from the Naval Research Laboratories. And to take a technology that was developed for long-range detection, primarily for sonar, and apply that in power systems. And in particular, the idea is to provide better information faster. That gives a picture of the grid that extends much further than conventional devices could possibly extend. In other words, you can see what is happening in the grid with our technology at greater distance, both in geographically and in time.
Well, did you find that just to follow up on some of that this sensor-based world, this digital communications, the improvements, and we'll get into some of this, and I just thought maybe I could tee it up here, is there's a constant state of innovation happening, whether it's in the national labs, whether it's happening with naval research backed, discovery. Your idea of a sensor world that is so dependent on communications, both from an analog and digital perspective, do you see that in the near term, sensor-based smart cities, smart grid, et cetera, are going to have positive impact on society?
Yes, and you see the evidence of that and what's already happened in telecommunications and in the the networked IT world. And frankly, for better or worse, the paradigms that we're all working with are paradigms that came out of the evolution of telecom. The fundamental difference is that telecommunications, beginning in the 1920s and 30s, built into its network infrastructure and into the equipment in the network, the ability to communicate with that equipment and for that equipment to report on what was happening on a network-wide basis. And that's only beginning to emerge in for example, in electric power. That network-centric view of the world and structure of how you approach your problems is just beginning to emerge in power. And it's something you have to learn. And it's something that you have to develop and implement the equipment that allows you to do that. For example, in the 1970s and early 80s, when you were changing over entirely to electronic switching and software-based switching in telecom, there were ways to make inquiries to the machines, to the switches throughout the network that were built into the equipment because of what had gone before. That's only beginning to happen now in power. And you're going to need that to happen. I mean, people talk about, the smart grid, we're going to be able to do this, there's that kind of, the answer is you're only going to get to a world of automated control and automated alarms that are grid-wide once you have upgraded the equipment. It's not necessarily upgrading equipment, but it's putting in devices that allow you to know what the equipment is doing. Sometimes you don't need to change the equipment. Our kind of approach at SmartSense, for example, would say you don't change the equipment, you just put in sensors that can tell you what the equipment is doing.
Yeah, I like that. And we're going to get into some of that unique value proposition from a sensor perspective. And I'm going to jump over here to Bruce. I mean, Bruce, this is where I think it would be great to kind of paint the picture of the complexity of arguably the most critical of the 16 sectors in our country. Folks, we're going to use a term, the industrial Internet of Things, and depending on where you look it up, it refers to the application of instrumentation and connected sensors, of all things, and other devices to machinery and vehicles in the transport, energy, and industrial sectors. That's a phrase that comes from the National Cybersecurity Center of Excellence, oh, by the way, and I think that paints a pretty nice picture. So Bruce, let's go to you for a minute. I mean, obviously, if you have a comment from Chris, but to tie in now this Grid Modernization Initiative, which you were leading, the concept of resiliency, and just this cyber physical risk dimension that we're faced with today. What are some of your thoughts, and tell us the state of the grid?
Sure. I'd like to build on some of what Chris actually said, because, one of the things that I did initiate when I was at the Department of Energy was the development of a North American energy resilience model. And that model is really the operationalization that Chris mentioned, wherein we were taking the system writ large at a North American scale and looking at ways to model it so that we could provide situational awareness, particularly against things like cyber physical threat or any other anomalies on the system. And what that really requires, as Chris noted, is the ability to censor the network, if you will, writ large. Much like after the 2003 blackout, where you saw this utilization of phaser measurement units, so too now with the North American Energy Resilience Model, you've got to enable and provide sensing in the system that will give you that situational awareness to identify anomalous behavior, whether it's harmonics on a system that are being introduced by things like inverter-based generation, whether it's other electronic devices being able to pick that up. And one of the key areas was the development of collaborative cyberware sensors, right? So you start coordinating the physical phenomena, which I think Chris is the sensing capability he's talking about. You take that electric phenomena, the physical phenomena of the world, and you start correlating it with some of the threat vectors and vulnerabilities that are on the system. And you start getting this very sophisticated picture of the entire situation, right? And recognizing the interconnectedness of the systems, and the sensitivity of the system. Having that forward look enables that ability. I will tell you, one of the things that we did in development of the North American Energy Resilience Model, with that, so too did we initiate a sensor technology and data analytics standalone program within my office to really move forward on technologies like Chris is talking about that have that real high fidelity, high throughput capability that can get into sub-cycle range capabilities of monitoring AC/DC anomalies for things like harmonics or geomagnetically induced currents. So there's a lot of capability, and when you then bring that down into a city type analysis, like you're leading, Pete, the opportunities really are they're layered, right? So the better information we have, the better our capability to process it and understand from a modeling perspective what the potential impacts are. Therefore, you can take that information and continually improve the system's capability.
Yeah, Bruce, I love it. And again, I'm going to frame up this next segment as we start diving a little bit into the secret sauce, not that we're going to trade or present what's behind the curtain, but really the value proposition of SmartSensecom, which I know for this audience is exciting, Chris. And folks, Bruce Walker just spoke to the grid and where we're moving towards, and you hear terms like smart grid, and there were some polysyllabic terms. We encourage you can go to energy.gov, you can go to the Ark, you can go to SmartSensecom and learn a lot of this stuff. But the fact is our infrastructure is aging. We could all agree, and we need a smarter, we need a more resilient grid. And to do that, we have to, and I feel, start taking advantage of the opportunity that the innovation and sensor-based concepts offer, and also mitigate risk. And Bruce, we'll come back to that a little bit with your.
Yeah, and if I could add, in addition to the aging component, it's really the increasing complexity of the system and this transition specifically from a large core generation pushing to this very dispersed and different types of generation that actually have kind of variable paths of supplying energy, right? So all of those things help drive the need for different capabilities that I think you're going to pivot to Chris and talk about, but we've got a rapidly changing system as well.
No, well said. And it's like real-time communication and information that we need. So Chris, These are some points that I think I hear a lot about in our community, and everybody inside the Beltway loves to talk about artificial intelligence, machine learning, and accurate data, and it can promise so much, but precision measurement, the term precision really stuck with me when I was doing a lot of research on your company, and sort of the technology, of course, without assumptions. Bruce's point, rapid, high precision of information, making decisions to save lives as we move into a world that we need more. Look, Mother Nature rains down on us. Physical and cybersecurity are issues. Can you talk to how your technology, let's jump in, would look to create more of that resilient infrastructure that's so needed, with some of the capabilities like optical sensing that we should feel good about as we move forward?
Well, fundamentally, what the technology that we have, and there's some other folks who are doing some similar things, and to a considerable degree, the various approaches are complementary. The fundamental of it is what is existed before: conventional measurement technology, sensing, if you want, in the electric power grid, whether it's distribution level or transmission level, has told you what's going on in a particular place or on a particular line, or really what's going on in a substation or with some transformers or on a particular line. And it begins to break down in terms of its ability to measure and detect when you begin to get anomalous activity. The very things Bruce was talking about, where the changes in how power is being supplied and power is being distributed, are creating the risk of anomalous activity, which can be damaging either to the users of the power or to the network itself. And what we do is, when things aren't going well, they're outside the usual parameters, we continue to measure very well. That's number one and most important. So right at the point where you really need the measurement so that you can take actions to correct the problems, or at least protect people against consequences, is when we continue to do what we're supposed to do and measure. And then, in addition, and very powerfully, because of the sensitivity and the resolution capabilities of the sensors, we can see much more deeply into the grid, meaning that we can see the activities of sources and uses of the power far down lines and through networks, both at the transmission and the distribution level. Now, all of that said, that's all capability. Where we need to go, and Bruce had mentioned this before, is we've got to begin to apply that capability and understand what it means. You got a lot of information. That doesn't give you situational awareness. That just gives you a lot of information. Situational awareness is built upon taking that information and beginning to understand it. And that takes time. We did that very effectively in the United States during the Cold War. I mean, one example, sonar. Another example is what we did with over-the-horizon radar. But in both of those examples, we spent decades developing the signatures, the understanding of what the information we were getting meant. And we need to do the same thing in power. We're beginning to do it. I mean, there's work that's being done at the Department of Energy. There's work that's being done by some of the major utilities. But it's a process. It will take time. But the first step in the process is you've got to get the information. If you don't have the information, there's not a lot you can do to mitigate the risk.
Well said. And that speaks to this world where cloud computing sounds wonderful, but it also screams volume, velocity, variety, veracity of data. And to steal from my whiskey room that I'm sitting in, distilling that data into something that I can actually understand and take action on, be it actionable or applied, is spot on. And I just want to offer this up to the group. I mean, you can go to SmartSensecom, you Google it, Bing it, whatever it is you do. Its secret sauce, in my view, are things like it's a transformational implementation of using machine intelligence. These are my words, Chris, so forgive me, I'm not the smartest tack in the room, but how we detect, monitor, and control grid infrastructure. It bakes in security and surveillance and detection in a way that's awfully unique and special. And as Bruce pointed out, the cyber physical threat to our grid today that's evolving, okay, whether you call it smarter or just modernizing grid, Bruce, you mentioned the Grid Modernization Initiative. I'm going to come back to you here on a little bit of that. This is a capability, or many capabilities with optical sensing, that I think folks are going to be very excited about. And maybe we'll talk a little bit about some of those use cases, Chris, when I come back around to you. Bruce, at the Ark, at the DOE, you mentioned some of your areas and the dependence on a lot of the research and development, microgrids, energy storage, cybersecurity, et cetera. I know you're focused on this risk, and with risk, we mitigate, we can't eliminate. Can you speak to some of your role currently and your dialogue? You spent years in a utility yourself. This convergence of OT and IT, what is concerning that should be acceptable, but also exciting about being able to truly modernize our grid for the future?
Yeah, so with regard to the Ark, and this is really the underpinning of what we're doing, right? We're clearly focused on national security and economic security, and we've recognized that finance and energy play a key role in that. To Chris's point, having a lot of information is not very valuable. It's really getting it and distilling it down, as you noted, into usable information. Well, the other side of that is to really understand within your own systems, what are those things that are so systemically important that, if they're impacted, would cause risk that's unacceptable, right? Or results that are unacceptable, right? So you don't want to have events that drop the Eastern or Western interconnect or ERCOT because they impact huge number of people, lots of defense critical electric infrastructure and critical defense facilities underneath, a lot of human health and safety components that need to be sustained. So while we have technologies that will clearly help provide the information, as Chris noted, for the technology within SmartSensecom, on the other side, it's identifying within the private industry, what are those things that I need to be able to understand the health of, have situational awareness around, so that I can do something about it on the front end, prevent, mitigate and eliminate the risk if possible, and then also build capabilities on the back end that if these things are realized, what are you going to do, right? So you think about some of the black start capabilities within the United States, and those are all changing based on the variability of generation, the different types of generation, changes in the generation fleet, and how that all works, right? So all of these things are happening simultaneously. I would note that, no different than some of the work that I was doing in the Department of Energy, one of the key areas you mentioned on was I initiated the Grid Storage Launchpad, right, which is about a $70 million project up the Pacific Northwest National Lab to accelerate the development of and utilization of megawatt scale storage. And the reason for that was when we had gone through and started to do our analysis, and you look at the myriad of ancillary services that get used on the grid, whether it's voltage control, frequency control, things like that, all of those provide stability into the overall grid, right? When you think of the interconnects, and bringing that capability in is great. But number one, you have to have the technology, right? So companies like Chris's bring the technology to bear, and then somebody's also got to figure out, well, what's really important to me, and where am I putting this technology to make it as useful, right, and purposeful as it could possibly be. So we had identified storage as a real simple way to basically stiffen the grid, if you will, make it more resilient and bring it together. So we initiated the storage launchpad just the same way I had initiated the sensor technology and data analytics, because we knew they had to both come into the model and be utilized by the model to then really provide that level of resiliency in the grid to support all the underlying functions that we've all come to, need.
Bruce, can I just quickly ask, having served and worked in a utility, I should say, not served,
Yep.
thinking of your support for our country in the military capacity, you have it in your DNA. How are you feeling that the utility sector, not one specifically, is embracing this concept of a smart grid? Is there early adoption? Is there late adoption? Do you think utilities are buying into, and not just energy? You mentioned the financial sector, but is sensor technology scary, or are people starting to see its value?
Yeah, so I spent most of my career in utilities really working on the operations side, and spent a lot of time working and running control centers. And the nice thing within the control center is you're dealing with models, right? And representations of the system you're trying to run, with developing what if scenarios, doing contingency analysis. All of that requires sensing capability, right? Better information, but again, it needs to be analyzed. It needs to be utilized in an effective way that it actually provides knowledge, situational awareness. So, when I spent 24/7 running systems out of the control centers, you have to learn your system, right? And you have to learn what's important in your system. Different sensing capability, different, smart grid type technology, that enables that insight into the systems that you're trying to optimize. But you've also got risk, right? So you talk about the IoT, events. Well, you also have to make those cyber secure, so that you're not introducing additional risk into your system for the sake of, more information. I would note that if you go back 30 years, 40 years, most of the utilities were using electromechanical relays. And, they had no connectivity to the internet or the communication pathways that, if manipulated and perturbed differently today by some of our nation state adversaries or others, can be manipulated, right? So you're dealing with a lot of physical components, and we have actually introduced some of the risk for the sake of trying to save money, economics, right? We used to man every substation in the United States. If you go back far enough, we don't do that anymore, right? We automate it, and through that automation, we introduce all this different technology, but we also introduce the risk. So there's a balance. I think utilities are embracing smart grid from the standpoint of they understand the efficiency concept, they understand the optimization of equipment, being able to use things like I'll give an example. So using sensing capability, right, what Chris is talking about, for dynamic line rating, right, to be able to optimize and increase the ability for a user to really utilize our transmission lines to the fullest extent. In the past, basically you would put a rating of a line in and you wouldn't exceed that rating, right? Or you would exceed it for a very short period of time. Well, there's lots of things that go into that rating. If you actually were able to sense the transmission lines and know exactly, what temperature and the exact amount of current and the reactive and real power going through it, and the ambient conditions, the temperature, or the wind blowing, all of a sudden you can start making better decisions as to how do you utilize that piece of equipment. And so utilities, they understand that concept, right? Because they've been running, the electric grid for over 100 years. And, but the capabilities of some of these things are new, right? The monitoring capability. You talk about great sensing. If you could pick up incipient faults that are on the system, or large power transformers or other transformers that are just about to fail, and you could predict it's going to fail, well, now all of a sudden I can avoid the event that might cascade into something else. And so there's lots of ways that utilities do embrace this today. But utilities are risk adverse, because they're providing a commodity that really is a lifeline. And so, they're not going to be the first to jump into the pool with new technology. They'll gradually, embrace it. They'll watch others embrace it, and then they'll learn how to use it on their system. And it's really a public safety issue.
Yeah, well, thank you for mentioning that. I mean, folks, we're using terms like critical infrastructure. There's 16 that our country defines as most critical. There's national critical functions, but we hope you're taking away from today that there's this opportunity with technology to underpin the sectors to create a society that has value, offer economic value to those owners and operators, which is Bruce's shared here is, the utility sector. And Chris, I'm going to come back to you because, again, I keep thinking about the technology that excites me. And if Joe or Joanne Sixpack is watching this today, I mean, we hear 5G, we hear telecommunications, we hear AI, and you make a sensor. You make a sensor that could complement the grid and its complexity today, right? It's not something you go in, buy, plug in on a transformer and say, hey, we're a smart grid now. There's still the integration and words like interoperability. I think of your company as one that's helping us get to that safer, simpler, more flexible grid of a future. And I applaud you and your team for that. So can you speak to maybe a use case or two, or where you're feeling like folks are, to Bruce's point, maybe dipping their toe in and saying, let me try these things out and share some of that feedback that you're seeing from the industry?
I think the core of the challenge is something that Bruce identified, which is it's not that people are opposed to new technologies, it's they don't understand them. So there has to be some education. And then even if there's education, people have to begin to, the people who are operating systems, designing them, have to begin to take into, as part of their work, this notion that they actually have a network, and that the way they need to design it is network centric rather than device centric. And a classic part of this in the world of electric power is there's a lot of sophistication in the substation today. But once you get above the level of the substation, frankly, forget the labels. Take it from somebody whose career is almost a half century long, largely in wide area telecom networks, and both for national security and other purposes. There's just a lack of sophistication in the tools that are applied above the substation level. And it's a lack of familiarity. It's something that's going to take time. And if you take a sensor system like ours, what it really amounts to is, in a very particular case, for example, the ability to identify, and to identify earlier in time, because you can see things that with the instrumentation, and you know that they're real phenomena and not artifacts. You can see them much earlier. And because you can see them earlier, you have time to respond to them. A classic case of failure because of not enough time was that once the oscillation on the West Coast, with a big blackout back in the 90s with the Northwest grid, they saw the oscillation that created it about 12 seconds before everything cascaded. With our gear, you'd see that oscillation about 2 minutes before. And that's the real fundamental of the difference. You see it in time because you're seeing it in distance and sensitivity, all sorts of reasons, but that then gives you the time to act and to correct the situation. That said, it's crucial to understand that you need to have networked this, that it doesn't work. None of this works, no matter what you're applying, our gear or anybody else's, unless you've approached it on a network basis and said, this is how we're going to apply it in terms of the network. And unfortunately, it's reality once again. When people think about equipment in power, they don't think about it as networked equipment. And therefore, the testing process and procedures are very different than I had worked with over the years in telecommunications, particularly in satellite communications, where everybody understood that I've got to do this at multiple points in the network. I've got to see how those multiple points interconnect and interact. And that doesn't happen very often in the power sector. Not because people, this has nothing to do with people's intelligence. It has nothing to do with people's willingness to accept technology. It has to do with the background and understanding that they have and the way they approach the problems. And that's going to change over time. But the other side of the coin is the whole question of what do I do with the information? What do I do with the now I see this oscillation. How do I respond to that? Identifying what the oscillation really is. The fact that it's not just an anomaly, but it represents some specific event, functionality, whatever, at some specific place. Almost everything that happens in the network originated somewhere. And what would be very important is to understand the origin and to understand exactly what that phenomenon that I'm looking at means. Okay, I see an oscillation. It's of a certain magnitude. It evidences itself in a certain frequency level. Okay, what does that mean? And how much information do I need in order to be able to evaluate origin and then to mitigate the effects of that? And part of that's going to take time. You're going to have to, over time, build a database that tells you that when the oscillation is like this, it's oscillation A, then that means that X, Y, and Z are happening. It's oscillation B, it means that R, S, and T are happening. That takes time. That development of an understanding of what the data flowing in actually meant and what the first level analysis of the phenomena meant takes a long time, and it's going to take decades. That said, you can use the new technologies immediately, particularly the sensing and so forth, to ameliorate a lot of problems that we're aware of that are very specific today. But in the long run, they will give you powerful tools to ameliorate lots of problems. The other thing is, if you do it right, it enables you to detect the kind of intrusion and problems without necessarily doing it through the network where the intrusions occur, because you see other phenomena that are outside of the usual parameters, and you say, huh, why is that occurring? So there's lots of work to be done. There's lots of power in the new sensing technologies, but at the end of the day, there's a great deal that we can achieve today, but in the long run, there's an enormous amount you can achieve, both to make things safer and more effective. I mean, one of the things, just as a fun point, that we love about our technology, and we've encountered it with the operating guys in the utilities, is unlike conventional CTs and PTs and so forth, our stuff doesn't blow up. If there's a problem, if you get a surge, something melts, some fiber cable. So it's very safe.
Yeah, and Chris, getting to Chris's point about this network kind of view of the world, that's exactly why we built that North American energy resilience model, right? Because that, you think of it as an onion, and it's got 50 different layers that all come together and start taking, and it's not only the electric phenomena, or you can bring in all sorts of other information to give you that situational awareness that, we need to have that, be able to not only react to it, but figure out how to automate it, use things like machine learning, AI, to, as soon as some of this is seen, which will accelerate the database, the library you're talking about, the signatures, Chris, to be able to operate the system in different modes and not have it as rigid as it is today, right? So it's a more flexible system that will adapt to what's happening on the system. And what's really critical is, this is where the Ark comes in, identifying those things that are that critical that you want to protect them differently. And the real easy example, your defense critical electric infrastructure. Yeah, that's really important. We want to keep those things available. But there's other systemically important pieces of equipment that cut across into Pete, to your point, the water sector, other parts of the energy sector, whether, the energy sector now is very, very broad. It's no longer just electric generation and transmission, because natural gas is now critical infrastructure that ties back into generation, because we've got about 40% of our generation, electric generation in the United States, fed by gas pipelines, right? So, and then comms is a whole nother layer that comes into this. And you start weaving these things together, you start getting some fantastic situational awareness. And with the work that we're doing to really understand the really systemic risk, you deal with those differently, right? And so, which is a little bit different than the utility model of the past, right? We used to feed all customers kind of generally the same. Maybe somebody would get 2 feeds, but that was kind of it. Now, as we get into this distributed generation model, which is a great opportunity, to increase the renewable penetration in the United States, that the amount of generation just by itself, right? Instead of having 6,000 or 7,000 units, we'll maybe have 70,000 units. Now you can utilize them differently and address your risk and really increase the resilience and reliability of the system, particularly those really important ones, right? And you got to look at it as a system, right? It's a big live system that's really the lifeline of so many other critical infrastructure sectors that you're working on in the supercluster.
Well, thank you for that shout out. Yes, we are. We're trying to not say the energy sector is the most important, but I think we all know, look, when I flip a switch on or a storm's happening, we all think, at least I do as a human being, right? Is my power going to go out? Will my car start? And energy or power is usually what kind of gets things going. And Bruce, again, anybody who does some research on Bruce will see that he was also and is highly involved with not just the energy sector, but your time, collaborating with the Department of Homeland Security and FEMA and all these wonderful places. And again, the ARC is very fortunate to have you addressing this risk discussion. I want to just follow up to Chris's points. And for those watching, again, this is an educational, informational, hopefully enlightening light bulb moment kind of chat. The technology of SmartSensecom and its electrical phenomena cluster platform, which is amazing. Please check it out. It also, maybe in layman's speak, if you think about the grid, and both of you, I'd love you to comment on this, but I know when I drive by these transformers and I see the distribution component, or a substation, and folks, it's geek speak to an extent, but it's the stuff we depend on. Things get old. Acoustics, pressure, strain, vibration, things that can impact the grid. SmartSensecom, in my view, is helping mitigate, or at least tell us when something might be happening sooner than we know traditionally through the decades of our grid and how it's been constructed. So Chris, that's my takeaway from you do and have great intellectual property. It's naval research backed. It's all about knowing something that might happen earlier and save life, to Bruce, your point. So I just wanted to, for my audience and my community, or my mom who's going to ask me after this, what's a CT and a PT? I'm going to say, Ma, it's not really relevant to you right now, but just know that stuff works. We're trying to make things better. Any comment, Chris, to Bruce's comments just now?
No, I think Bruce's comments are absolutely fair.
Yeah.
And it's the resilience model is frankly one of those moments when the federal government gets it exactly right. And it's something that can only be done. We tend to forget, and I'm a conservative guy, and till recent events, I was a lifelong card-carrying member of the sort of a little bit to the right of the center. But there are things the government does. And one of them is to make sure that things that are common, that we share significantly, that they get managed properly. And it's not by government managing it, but it's by government creating models for management and overseeing that management. And I think that's a lot of what the resilience model is about. And that is exactly where we need assistance. In telecom and IT, for example, everything standardized, right to the shape and the materials that you can use in a plug that you plug into your phone or the wall or whatever. Now, in power, as I've learned over the past decade, beginning to work with this, you don't have that same level of standardization, not even in terms of the electronic equipment that it uses. And frankly, that's not a good thing. And the more that we can encourage people to think about this similarly and to standardize the interconnection of the devices, we'll be achieving a lot. And that really can only be undertaken by government. So to sort of expand on what Bruce said, yeah, I think that there's a clear role, and there's a lot of cooperation that has to go on between all sorts of functional organizations. Forget whether they're government or private sector, it doesn't really matter. It's just they're separate entities. And they've got to agree and they've got to work together. And if you want our modern world, it's based upon petroleum and electricity and computers and connecting them together or telecom. And those are the things. Without it, we don't have the modern world. We can't feed ourselves. We can't run things. We can't keep the pumps going. Back in my hometown of in Colorado, and the pumps are very important.
Of course, the ping power and the pipe and the plumbing really is that network of networks. And folks, again, just Google the electric grid. Look how complex it is, again, to steal Bruce, your term from early on, and just appreciate it's a marvel. It's an engineering marvel that needs a little bit of a reimagination as we move towards this world that depends on communications. All right, we're going to move close to our parting shots, because I mean, I just think this will hopefully have been a primer for people. I know our audience is super excited. Before we go to those, though, I'm going to ask Bruce and Chris, or each of you, one lead. Bruce, you first. The ARC, how can folks engage? If that is there an opportunity to be a part of the discussion? Chris, obviously, in your case, there will be people who will reach out to me for sure and say, hey, I want to see a look or take a look at one of those things, and they can go to your website and contact you. But maybe you want to share how to engage. My summary of the last conversation, really quick though, was we've talked a lot about a smart grid. Diagnostics are so important. Transformer resilience, folks, not just reliability, and transmission reliability. All of that is what SmartSensecom and the work that Bruce has done and is doing in his new life. Power balance, power flow, though, and optimum consumption. That's speaking to the world we're moving to. And I think my buzzword will be DERS, distributed energy. Okay, we are learning every day of the week. Every time there's a natural disaster, every time there's a cyber disaster, there's something that's revealing this infrastructure that needs to be optimized. And again, I shout out to SmartSensecom and the folks, Bruce, that you're working with to kind of bring this grid to one that will help save life and make human beings appreciate, or that we're fortunate to have great folks like yourself behind the scenes. So there you go. Bruce, how do people engage with the ARC?
Well, the members we have are the ones that we're working with, and their best opportunity would really be working with the federal government in support of whatever critical infrastructure they have responsibility for. And we are continuing to figure out what the best partnership and the different venues within the federal government to work through to really get the best information and really the best solution for identifying as well as mitigating the risks associated with keeping the power and the lights on.
Well done, well done. And I again know that you're bringing those communities together at a time when we have to, and hopefully people bring and drop the ego at the door and say, hey, look, we're all after that greater good. So thank you. Chris, what about you? SmartSensecom, opportunities to pilot, partner. What would you say to the audience?
Well, our gear is designed for utilities or for power generation facilities. So we're talking about an audience that's not all that big that we directly address and that we interact with. But we're available to do that. and we're happy to work on pilot projects with people. We're a little company. You know, we're not like one of the big vendors. We can't go out and underwrite these things ourselves, but we're happy to participate in it. And we're certainly happy to work on design and similar considerations with people. At the end of the day, this is new stuff though, and we're learning as we work with others, and we work with the national labs in several projects. You know, we're learning about it. Other people are learning about how it works. And, you know, there's more than a little bit that needs to happen. It's just a dialogue, and we're happy to participate in it. People want to come talk to us if they want us to come talk to them. We're delighted to do that.
Well, I appreciate that. And we will be following up, and I will be facilitating that personally, because we need this kind of conversation and dialogue. I have to give a shout out, Bruce, Pace University. I mean, one of my most favorite people of all time, God bless him, James Lipton, not a bad guy, has taught me a lot about a conversation that is supposed to be educational. And when I saw that in your bio, I was like, man, Bruce is one hell of a storyteller. Maybe that's something that Lipton left with the community of Pace. So, all right, Bruce, that was a little bit of suck air out of it, so you could think about parting shots, folks. It's 30 seconds to a minute, maybe. Just what do you want to leave with the audience today? We talked about a lot of things, a little bit technical, a little bit human, but humanize a bit of this conversation. What would you like to leave with the audience, Bruce?
Yeah, and thanks for that. I think, you know, I think people, number one, recognize that energy is critically important to so many different aspects of our lives, whether it's national security or just down to our personal lives. You know, I think the understanding and the situational awareness of the system, and understanding that you know, we are faced with a lot of different threats today, many of them man-made, cyber, physical threats. We have to be thoughtful as we continue to work with evolving the system. The system is changing very, very rapidly, and it's something I know you guys are working on through the Supercluster. And as you bring together all these different technologies and the DERs, as you mentioned, and the system fundamentally changes, right? These are fundamental changes of the system. You know, I think that has to be done very, very thoughtfully, with a mind towards long-term management of risk, right? So where I think smart grid started, and where, you know, you look at things like AMI meters and things of that nature, you know, we put a lot of pieces of equipment into the system in a very, very quick way. But I don't think we engineered all of the cybersecurity and other risks out as well as we could and as we need to. What I'm hopeful is, you know, as we progress down the path of integrating more and more renewables into the system, solar, wind, bio, you know, different types of hydro, micro storage and megawatt scale storage, we need to be conscious of how we're putting these things together, because at the end of the day, we're dealing with physics, and we really need to be able to push those electrons where it goes, you know, to provide the support, the power, the lifeline, if you will, to the cities that make up our countries, and to the people that live in those cities, right? So I think we've just got to make sure we build this into the process. I think Chris alluded to this with the telecom industry, right? They built many of these things into the process through their evolution. I don't want to end up on the other side where we've got, you know, 25,000 new distributed generators out there that have not been coordinated, have not been cyber protected, and then we end up with a more exacerbated problem. So I think, you know, I think people should just incorporate risk, really take a look at it as they're designing the system, and we'll all be better off at the back end of this thing. And really, it's an opportunity, right? As we transition the system, it's also an opportunity to transition our capability in threat protection in that system. And I'm really hopeful that as we advance, you know, that opportunity really manifests itself and comes to fruition.
Wonderful. And I love the mention of just integration and interoperability. There's a lot to consider. It's a tough task, but your leadership's extremely needed. So thank you for that, Bruce. Chris, parting shot, my friend.
Well, looking at those very questions of interoperability and the expansion of sources, you need the capacity to understand and monitor the network that's not reliant on the core machines in the network, but separate from them. And that's something that's going to require an overbuild by the electric utility industry. And it's one that they're going to have to adopt in some way. Nothing, doesn't matter whether it's our technology or something else, but it's going to have to happen, particularly so that interoperability can be sustained. Bruce's point is well taken. It's wonderful to have 25,000 sources, but they've got to work together. And if things go wrong in some geographic area or with some part of the technology, you've got to be able to rely on drawing from the other sources and interconnecting properly. And we just got a huge lesson on that recently with Texas. That was a failure of design, but I'm not saying it was it was a failure of design in the sense that people didn't think through what might happen. And they got a worst case situation, and they didn't have the kind of infrastructure in place that enabled them to solve the problems for Texas. Whereas other parts of the country that got the same tremendous, unparalleled cold and so forth, were able to sustain operations or return to operations much more quickly. So but all of that depends upon knowing what's happening and being able to assess what that means. So Bruce's situational awareness coupled with good information.
Well, thank you. I was waiting to hear more because you're just, you talk and you wax so eloquently. Thank you. Hey, look, Bruce, shout out. Fired up to know you, man. I appreciate all you did for our country, serving in government and what you're doing now. And it's a blessing to know you. And I commend your purpose and your passion. Same, Chris, your brilliant mind and the team you have at SmartSensecom is, to me, representative of what's needed. That entrepreneurial spirit, teamed with government intervention and funding and investment by the industry to really move this needle, if you will, and create a safer life for human beings. So thank you both. The Supercluster is going to stay in touch, of course. I'm excited to get this produced and pushed out. And thank you again for your time, and we'll talk soon.